Hello everyone, today we're going to be doing LeetCode number 814, binary tree pruning. The problem description says, given the root of a binary tree, return the same tree where every subtree of the given tree not containing a 1 has been removed. A subtree of a node is node plus every node that is a descendant of node. So right here we have the example number 1, showing that we get rid of this node right here because it doesn't have any its subtree itself doesn't have any children. That is a 1, and it itself is a 0, so it should return null. So let's kind of walk through this with paint just to understand what we're gonna have to do. So I wrote down as two basic examples. First, we have this tree right here. So this is a root here. We're gonna start off right here. So what we're gonna want to do is get its left child and its right child, and then we're gonna do some comparisons with that. So the very first thing is we start off right here. So we're gonna but the base case is if we're given a node that's null. Well, if it's null, then we're just gonna return null. So that's our base case. So knowing that base case, we're gonna start off right here at this node. So we're gonna check its left child first. So let's check the left child. Well, the left child is null. That meets our base case. So that means that the left child is gonna return null. Yeah. So now let's check the right child. So the right child is also null, which meets the condition that if the root is null, then we return null. So it's going to return null to its caller. Okay. So now we have two children that are null. So there's not a 1 existing within its subtrees. So now what we're going to check, since both of its children return null, saying there is no ones like in its subtree. Now let's check if the node itself is a 0 or a 1. Because if it's a 0, then that means there's no ones at all within here. But if it's a 1, then there is a 1 existing. So in this case, both of its children are null, and the node itself is also 0. So that means we're going to return null. That means there is no ones at all. So now let's go on to this example. For this, we're gonna check the same thing. We're gonna check the nodes left. Okay, so the nodes left meets the base case. So we're gonna return null. We're gonna check the nodes right child, and we can see that it's null, so it's gonna return null as well. Return null. Okay. So now we're gonna see, okay, since both of its children return null, so that means there's no ones existing within any subtree of this node. Okay, so there's no ones existing. Is this node itself a 0 or a 1? If it's a 0, we're going to return null. But if it's a 1, we're going to just return the node itself. But we could see in this case that it is a 1. So that means there is a 1 existing. So what we're going to do is just return it. We're just going to return the node, which is just 1. Okay, so now once we have done smaller examples, this logic will work on bigger examples. So this is the example right here that they gave us right here. I drew X's just to display that these are null. So okay, so if we start off with 1, let's do the same logic that we applied on these problems, but on this bigger example. So this is a 1. We're gonna check its left child. So the left child is gonna return null because it meets our base case. Okay. Now once we check its left child, we're going to want to check its right child. We're going to check its right child. Okay. This right child is going to check its left child. All right. Now this node is also going to check its left child. We can see that its left child is going to return null. So this child is going to return null to caller. And the same way, we're going to check its right child, and we can see that it's also null. So it's going to return null. Okay. So now when this one return null, now once these both return null, So now we're gonna check the same condition. Did both of its children of this node return null? Well, yes, it did. Is this node itself a 0 or a 1? Well, in this case, it's a 0. So that means we're gonna return null like we did on this one. So now we're gonna return null. Okay. And we're gonna go back to its caller, just right here. And now we're gonna check its right child. Its right child. And we're gonna check its left child and its right child. So we could see that the left child is null, the right child is null. And finally, we're gonna check, is this node itself a 0 or a 1? Because in this case, both of its children return null. So in this case, it's a 1. So if it's a 1, we're just gonna return the node itself. So we're just gonna return the node itself. And as we can see right here, since this one returns null, we're gonna get, it's gonna look like this. Since this left child returned null, it's gonna look like that. And we are just gonna be something like this, 1, 0, 1. Yep, and we're gonna have 1, 0, 1, which is what we want. 1, 0, 1. Let me just delete this, make it clear. And we are gonna be left with something looking like this, which is the solution that it wants. Okay. So now that we've kind of walked through the logic of what the problem wants, we could actually put this into code. So we said that our base case was if root is equal to null, we are just gonna return null. Okay. So now we are gonna want to get its left child and its right child. So the way we do this is root.left is equal to prune tree, passing in its left child, root.left. And we're gonna do root right is equal to prune tree root.right. Okay, so now once we have its children, we're just gonna want to return something. And the way we return is we're gonna do a ternary operator. We're gonna do return. So what was the case? Well, the case was if root.left is equal to null and root.right is also equal to null, and the root itself, root.value, is equal to 0, we're just gonna return null. Otherwise, we're just gonna return the root itself. So again, in this case, both of its children were null. So if root.left is equal to null and root.right is equal to null, and the root.value is equal to 0, then we're just gonna return null. Otherwise, in this case, the root.value wasn't 0, we're just gonna return the root. And if it works on these cases, then it would work for these bigger examples. So let's kind of just run the code to make sure I don't have no bugs. Okay, let's submit. Cool, we can see that this works out perfectly. Okay, and that's it for the problem. If you guys have any questions, just leave them in the comments. I'll answer. Other than that, thank you.